Okay, so we're going to apply what we know about waves, and we're going to look at it in terms of math. So you have really two equations that you need to know and memorize. You will not be given these equations. You will be given the constants. Okay, so the two equations that you have to know are this first one. C is equal to wavelength times frequency. So that upside down Y is wavelength. And the V is frequency. The C is a constant, and you're given it right on the paper. Okay? That's the speed of light, just in case you wanted to know. The second equation is energy is equal to Planck's constant times frequency. So E is equal to energy. It is not a constant. H is a constant. It's right here. And then V is frequency. Okay, so frequency is the common thread through both equations. So there will be many problems where you are asked to find the energy and you're given a wavelength. So you're going to have to find frequency before you can calculate energy. Okay, and then just to remind you, this unit of hertz is 1 over a second. So when we're doing stuff with Planck's constant, your units will cancel. It's not going to be as pretty as when we were doing dimensional analysis, because you have to keep in mind that we're going to be using hertz. We're not going to use this equation. We're only going to use those first two and the two constants. All right, so let's work our first problem. A certain photon of light has a wavelength of 422 nanometers. What is the frequency of this light? So first, I'm going to tell you to go ahead and define your variables. So this is wavelength. Okay. What is the question asking me for? Frequency. So I want to know V. Which equation do I have that relates frequency to wavelength? The first one, C is equal to wavelength times frequency. Now, I have a wavelength. I'm looking for frequency. Do I know C? Will C ever change from the constant value of 3.0 times 10 to the 8th meters per second? No. You always know C. Okay. Keep in mind that when you're doing these equations, you always have one constant. You have C and you have H. So I know C to be equal to 3.0 times 10 to the 8th meters per second. All right, look at your constant. Look at the units on your constant. Meters per second. Is wavelength currently in meters? No, it's in what unit? Nanometers. So can I relate meters to nanometers within the equation? Or do I need to convert first? I need to convert first. So let's use dimensional analysis to convert between nanometers and meters. 422 nanometers over what? 1. Where does nanometers need to go so it cancels? On the bottom, what's going to go on top? Meters. Nanometers. Okay, 1 nanometer is equal to what? 10 to the negative 9th. Okay, nanometers cancels. I'm left in meters. So when you do that math, what do you get? Good. 4.22 times 10 to the negative 7th.